finding equivalent resistance across the points A and B is. So in this circuit, if you look clearly here, you will find that there is a symmetry between A and B, as we can say that corresponding to 6 ohm resistance over here, we have a 6 ohm resistance over here, 3 ohm there, we have a 3 ohm here, 4 ohm here, we have a 4 ohm here, 6 ohm in between, we have a 6 ohm here in between, 12 ohm here in between, we have a 12 ohm here in between. So I can say that there is a perfect symmetry that exists in this particular circuit, and hence whenever I will be solving this circuit out, I mean to say that we will find out the equipotential nodes. So I can say that H and F are equipotential nodes, E and I are equipotential nodes, J and D are equipotential nodes, C and K are equipotential nodes. So when I say that these nodes are equipotential, I can redraw this circuit in such a way that we begin this way, that between A and G we have a resistance of 1 ohm. Now this point over here we are considering both as H and F. So I mean to say that this 4 ohm and this 4 ohm are in parallel with each other, and they will give us an effective value of 2 ohm. So if I would have drawn it by overlapping the two nodes, I would have drawn it this way, and this 6 ohm I would have overlapped with the another 6 ohm resistance like this. I would have drawn the entire circuit this way. So I'm not drawing this circuit, I'm drawing the calculative circuit because the calculations are simple. Both the resistances are same, so we just have to half the value. So between these two we are getting 2 ohm, and between the point A and H and A and F, both these 6 ohms will combine together in parallel to give us 3 ohm. So this will give us value of 3 ohm. Now we move to point E and I. Now the point E and I, this is 3 and 3, so in between we will get 3 by 2 ohm, and over here we will get again 3 ohm because there is a 6 ohm resistor. Between E and D, which is equipotential with J, we again have 3 ohm on top and 3 ohm over here, so we'll get a value of 3 by 2 ohm, and the two 6 ohms between A and D and A and J will give us the value equivalent of 3 ohm. Now we are going to C and K. The value is becoming again 3 by 2 for C and K, and between A and C or A and K, the two resistance that we have of 12 ohm will give us the effective value of 6 ohm. Now from C to B or K to B, the 6 ohm resistor can be, the two 6 ohm resistor can be drawn as 3 ohm. So this is how our effective circuit is going to look like after considering all the aspects. Now we start solving it. We say that these two are in series with each other, will give us 3, and this 3 and 3 will give us 3 by 2. Again this 3 by 2 and 3 by 2 will combine together to make it 3, which in comparison with 3 in parallel will become 3 by 2. So again 3 by 2 and 3 by 2 will make it 3, which in combination with 3 will give us 3 by 2. Again 3 by 2 and 3 by 2 will make it 3, which is in parallel with 6 ohm. So now I write that R parallel is equal to 3 into 6 upon 6 plus 3, that is 9. So we get 2 ohm. Now this 2 ohm is in series with 3 ohm. So we get this as the effective value, which is equal to 5 ohm. So for this circuit, 5 ohm, that is option A, is the correct alternative.